What I'd like to do now is show you how to use SPSS to conduct a factorial analysis of variance. In this case, the factorial Anova has more than one independent variable. Uh, so in this case, we're going to have two independent variables and one dependent variable. So I'm going to take an example from our course pack on page 110. And this is the special education data example. And for this example, we're going to compare schools, high school versus elementary, on the mean number of evaluations that are conducted. So students are referred for special education, and oftentimes they're evaluated. But in many schools, they use interventions prior to just testing them and placing them. And so the three methods of intervention that we want to look at are the mean number of evaluations conducted in high schools versus elementary schools that just use the test and place method versus the mean number of evaluations done in high schools versus elementaries who use both teacher assistance teams and collaboration, and then compare the mean number of evaluations across high school and elementary for schools who use just teacher assistance teams. The other thing we'll also do is compare the mean number of evaluations done regardless of school at test and place, at TAT and collaboration, and TAT. And you can see on the next page how the data can be set up in SPSS. So you have the number of evaluations conducted across schools, and then the number of evaluations is labeled for each type of school. One is high school, two is elementary. And then within each school type, you have the intervention type specified. So you have the test in place is a 1, TNT in collaboration is a 2, and then 3 is just teacher assistance team only. So this is the way you need to enter the data into SPSS, and then your spreadsheet is going to look like this. Now once that data is entered, you want to go to variable view and do some labeling. And so for the eval, its evaluations, you can label that. That's the number of evaluations conducted. And then for this is the intervention, so that's where you label this as a 1 for test and place, 2 for TAT and collaboration, and 3 for TAT. And then for school, that'll be a 1 or a 2. So it'll be high school or elementary. Okay? So now we'll go back to data view to do the analysis. So I'm going to go up to Analyze, General Linear Model, Univariate. Now in this case, we'll put evaluations in the dependent box, interventions in the fixed factor box, and school in the fixed factor box. Now for our plots, we want to have the intervention method on the horizontal line, and we want to have school on the separate lines because we want to compare the number of interventions by school across those three different intervention methods. So we'll go ahead and add that, and then continue. For our post-hoc tests, we're just going to add intervention, and we're going to check 2D. Now the reason we just add intervention is because there's 3 levels, and so SPSS will do post-hoc tests for factors that have more than 2 levels. For the school factor, a post-hoc test will not be done, and if the school factor is significant, all we have to do is look at the means to see which one is significantly higher or lower. And then we click on Continue, and then we go to Options. And I like to get the overall because the overall mean is actually the grand mean. So that's the mean that all the sums of squares are calculated from in our Anova summary table. And then the descriptive statistics, the estimates of effect size, observed power, and the homogeneity tests. And then we click on Continue. And then we click on OK to And so now you can see that our variables, of course, are labeled by their level, and we have 10 in each. Intervention method level, and then our schools are also labeled 1 and 2, and we have 15 high schools and 15 elementaries. Again, please check these numbers to make sure that they're correct and that you coded your data correctly. Then we get the high school and elementary mean number evaluations done by each intervention method. And then we get the total mean. This is the grand mean here. Okay, we have our Levine's test, and of course it's non-significant, which is good news, so we don't have to worry about violation of assumptions. We see that in the test between subjects, this is now our Anova summary table that we look at. So we have 3 lines that are very important to look at. Intervention, so that's one factor. And you can see intervention method is significant. So that means that at least one set of those interventions differ on the mean number of evaluations conducted. The partial eta square, which is very strong, is 0.442, which means that 44% of the variability in evaluations is due to differences in intervention methods. And then our power is very strong for that particular outcome. If we look at the school factor, it's also significant. And we can say then that the number of mean evaluations differ across schools. Our partial eta square is large, but our power is small. Then we can see the intervention by school factor is non-significant. And what that means is that we don't have a confounding effect where we have schools that differ within some interventions on mean number of evaluations and not others. Then we can go down to our post-hoc tests, and we can see that TAT and collaboration, when compared to test in place has a significantly higher number of mean evaluations, as well as test in place has a significantly higher number of mean evaluations when compared to just TAT and collaboration. However, if we compare TAT and collaboration to just TAT, we can see the mean difference is negative 0.5, which is not significant. Then we have our homogeneous subtests, and then our profile plots. And we can see that when compared, TAT, when compared the high school to the elementary, there's a difference there, but the difference is not significant. And all we have to do is, well, let's see, the difference, so we do have a significant difference. And if we look up here, what this means is that this high school mean, overall, the total mean, is significantly higher than the elementary mean number of evaluations. And so that's across intervention methods, but we don't have high schools and elementary differing within particular methods. It's just that high schools overall have significantly higher numbers of mean evaluations conducted than elementary schools, regardless of their regardless of the type of intervention method that's used.